Yes, let's continue from where we left off. Okay, web services. Everything we're talking about here now is service-oriented architectures and so on are typically implemented or set up in open environments. And what are the features of open environments? For example, components of information systems cross organizational boundaries. So you want interaction between organizational boundaries. For example, Slack, that's a perfect example of a service-oriented system which utilizes information from different kind of sources where you can hook them up into your Slack software. These are cross-organizational boundaries. Typically, what you have in open environments is autonomy, and environment's components is solely under own control. So a component is the master of its own information. Heterogeneity. Components are different in their design and construction. It doesn't matter how they are built. What matters is that they can communicate and they can interact. Dynamism. Autonomous components may change their presence and behavior. So what we got then? We got N-tier architecture instead of 3-tier architectures. What is 3-tier architectures? Have you heard about that? MVC. Mod View Controller. And typically in Mod View Controller type of systems, you have a client, you have a server, and you have a database. These are the 3 tiers that you have. But in N-tier architectures, you maybe have a server that finds information from different kind of sources. Other servers, other services, working and finding information from there. So then you got more tiers than 3. You have got 1, 2, 3, 4, 5 tiers in this example. One way to implement service-oriented architectures is using web services. And how does web services work? Typically in web services we have a service user, and that's not a human user, that's another service. You have maybe some kind of intermediary, and you have a service provider, and you have a service registry. So typically messages goes between the service users and the service providers. And the service provider publishes metadata to a service registry. Maybe the service user could find this metadata and locate different services that are nice to have for this service user. So typically you have a service user, service provider, and a service registry. In web services, we are talking about service providers, service brokers, and service requesters. The technology stack of web services, because these are standards. You have service lookup, UDDI. You have service description with WSDL. You have service access and messaging with SOAP. And you have serialization format, typically XML, but it can be other serialization formats as well. And you have communication upon the HTTP protocol. So these are protocols, typically SOAP over HTTP. Okay, communication with HTTP, XML, and you build the SOAP, which is an standard based on XML. It's XML-based standard. WSDL is that as well. That's for service description, and service lookup is UDDI. That's an interface. It's a defined interface for how to look up services. Yes.
Can you just briefly describe SOAP?
Yeah, we'll come to that. Yes, later in the lecture. Now, actually, service access with SOAP. SOAP messages. These are XML-based messaging formats. In HTTP, you remember we had this text header, and typically the body of the HTTP was either text or XML or HTML or whatever. In SOAP envelopes, we also have a header, envelope header. That's for metadata. Encryption information, access control, routing, data extensions, etc. And you have an envelope body there as well, with operation request and maybe parameters that you want to send with the operation. Remote method invocation, you remember we talked about that? These are the operations that you invoke. Or if it's a response, you have the operation response. This is a sample SOAP request. You see that it's a lot of overhead, typically with XML namespaces in these envelopes. That's maybe one of the reasons that JSON as a serialization format without SOAP or anything else over HTTP, clean HTTP, is more popular now than SOAP. But the main thing is that SOAP, this SOAP envelope, states what kind of method we want to invoke on the other server. It says here, get production year. That's the actual method that we want to invoke. Okay? And with this function or method that we invoke, we pass parameters. Performer name, and the value of performer name is Pink Floyd. And we pass another parameter, album name. The value of the album name is The Wall. You also state the types, the data types that you're sending. Whether or not it's a string or an integer or a float or whatever. These are strings. Okay? So these are actual SOAP requests. So on the other hand, where the service that accepts SOAP requests handles this SOAP envelope, parses it, and marshals it to its own rule set, more or less. So there, on the other hand, you have this function that is called get production year, and it acts upon that. It uses the function get production year and passes the parameters Pink Floyd and The Wall, and it sends a response back, which is also SOAP. Any questions to SOAP?
Compared to REST, SOAP was more popular before REST kind of took over, as I understand it. And the way I see it is that REST is far more simpler than SOAP. And why did they start off with SOAP? Why didn't they just jump to REST, which is just an XML message compared to SOAP, pretty much?
Yeah, the thing is that REST actually, the article that first of all initiated this call of REST using HTTP for this kind of communication That was written before SOAP was an actual standard as well. So why does this happen? This is great for machines. Do you remember, I think it was the last lecture or the lecture before that, you asked why
It was something about why they accepted more less strict HTML.
HTML, less strict HTML instead of XML-based HTML. That was what you asked. SOAP hasn't been completely adopted by the ordinary computer scientist and the ordinary programmer. Because of this, because of the overhead, we can't program this. Typically, SOAP envelopes are made by enterprise frameworks like Java EE or Microsoft.NET. You have some kind of wrapper there that fixes this for you. So you are more or less just doing your function calls in your programming just as you do any other function call. And then .NET and Java EE fixes this for you. It wraps everything in a SOAP envelope, sends it to the other server, and gets some response back and unmarshals this, as we say, and into a variable that you use from there. What happens then? You need this large framework, or you need some kind of library, so you're dependent on these kind of things to implement it. And what happened, I think, that's my theory, that REST is quite easy to understand, it's quite easy to implement, it's quite easy to set up quite rapidly. So what happens then is that the programming community, the developer community adopts REST because these are quite easy principles and they are quite good as well because they solve more or less the same problems. But there are some cons here. Why? What is better with SOAP than with REST? You can ensure, because here you have another wrapper format more or less with metadata. So you can put in a lot more metadata like encryption, security in different kinds of ways. You can provide the description of how your services should compose, what kind of authentication mechanisms you want, a lot of different things that you have the possibility to do in HTTP protocol as it is now, and as it will be in future as well. So we'll see that when we come to the WSDL standards, that SOAP actually provides a lot more features than HTTP does. But still, the REST APIs is where the developer community has gone in the later years. So maybe this is too complex, too difficult. You can't write it by hand. And maybe that's the problem. Of course, you can write it by hand, and then you use a lot of time. So you typically use some kind of SOAP library to do this for you. This is a sample SOAP response. Here you get a response, get production year response. It's of type string, and the response. This is the small string that you're passing back to the service that did this request. 1994, wrapped in this big thing here. You see there is a lot of overhead. And that's one of the cons with SOAP as well. Because SOAP is used over HTTP, so you have your HTTP headers and you have your SOAP headers, and then you have this little variable that you want to pass, and that's a lot of text for one piece of text, 1994. There are different styles of communication with SOAP. First of all, you can do remote procedure calls, like in examples, or you can do XML document or fragment exchange. Then you wrap your documents, either HTML documents or XML documents or whatever, within your SOAP envelope body, instead of a variable that you pass back. You can use it in different ways. Type-bound values, which is encoded, and type-unbound values, which is literal. So then you got 4 possible combinations, but there are only 2 commonly used. RPC type with encoded type. Encoded usage. You have document type and literal usage for exchanging XML documents. So this is RPC centric. This is like remote procedure calls. You have RPC and encoded usage. And this is document centric. Okay, what are SOAP limitations? It's a character-based protocol. Easy to handle, but may result in much text overhead for short messages, as we saw. It's a stateless protocol. In itself, it's a stateless protocol. You can pass metadata in other standard specifications, we'll come back to that, to enforce states, but SOAP in itself is a stateless protocol, as HTTP is stateless. So it limits the possibility for bi- and multi-directional communication unless the system uses some kind of conversation identifier. That may be a text token or something like that. It's limited support for enforcing security between peers and client servers, but this is also enabled by other specifications. We'll come back to that as well. Okay. SOAP in PHP. Here you see what I mean by whenever you're using SOAP, you're just using it as any other function or any other library. Because you're instantiating a new SOAP client, and the SOAP client makes all the magic happens. So the SOAP client wraps everything that you use into SOAP envelopes and handle the SOAP responses that get back. So you use it by instantiating a new SOAP client, maybe have some parameters. That's an ordinary array. You do a request to get whether this method. It seems as like a native method, like a method within your PHP code. But typically this is just set up by the SOAP client. It's more or less a fake method. It does a method call to another server. You pass the params, and maybe you print the response. This is a more elaborate SOAP example from Java. You can look into it if you want. The main thing here is that you handle the SOAP request and response yourself. What I did in PHP here is that I provided what is called a WSDL file. We'll look into that as we go on. But this WSDL file says to the client that this is the API that you can use. And so the client parses this WSDL file and knows that the other service has a get weather method. So it marshals objects based on this WSDL file. It's not that easy in Java, that actual thing, marshalling from the WSDL file. Because in Java you need some kind of pre-processing tool that sets up your, it can't do it in runtime. It sets up your libraries. Maybe I think there's a command tool to do this. I don't remember what it was called, but you can use that command tool, provide a WSDL file, and it instantiate, or it doesn't instantiate, it builds classes for you that resembles the API that is described in the WSDL file. Here we have to have some kind of minor handling of the SOAP body, as you see. This is a Node SOAP client code snippet. I won't go into detail here either. You use a WSDL file, and that describes your API, and it makes an object with the same API natively, get city weather by zip, and you pass the parameters as if it's a native function. This is an example of a Node SOAP server. We'll go into detail on that. You can look into it yourself. Okay, so I've already talked a little bit about WSDL files. These are for service description, describing what kind of methods the API exposes, describing what kind of types and parameters you need when you invoke some of the remote procedure calls, and so on and so on. It's an XML format for describing web services. Okay, let's look at WSDL 2.0 because that's what's interesting for us. You can describe what services that are provided by using what's called the interface tag. You can describe the operations with the operation. You can describe the message format that's not available in WSDL 2.1. 0. The data types that you're exchanging, what type of technologies can be used to access the server, like if it's a REST server or it's a SOAP binding. Let's see, can we look at this example maybe? It's quite large. You see that these are not specifications made for humans, not for developers. These are specifications made for computers. So that a computer can fetch this WSDL file, parse it, and make classes based on what kind of interfaces we got here. But let's look at if you can find some of the elements that we talked about. Typically quite down here you have a WSDL service with a port, and you have an address. So the endpoint for this service is WSF cdyn.com weather.asmx. So if we want to call this service, we have to use this address. Okay, this URL. You also have some operations defined here. Get city weather by zip. Okay, so that's located in /get city weather by zip. It says what kind of input it wants. It wants URL encoded form parameters. and it says that XML is part of the body. With the whether HTTP post, you define the binding. It's a post binding, so you can post to this operation, get weather information, so you can post data there as well. So this is WSDL. Typically, as I said, WSDL files are parsed by libraries that knows how to parse this. Okay, based on the WSDL 2.0 specification. WSDL content, it's a description of interfaces of web services. So it's the endpoints that you can reach the web service, what kind of methods you got, and so on and so on. Typical structure of WSDL. You have the root element, and in there you got the message formats with the type elements. You have the interfaces that are provided within interface elements, and you have bindings of these messages to a protocol with the binding element, and you have the location of the service within the service element. Yes. So what happens then when you use a SOAP and WSDL library in your client code, like PHP or Java or whatever? Client application inspects the WSDL file, parses it, and marshals, as we say. Marshals a new object based on this specification. So the object is quite similar to the API that is exposed by the service. So you can use it more or less in your programming language. Then it communicates based on this API specification with SOAP. Some WSDL examples, if you want to look at them yourself. What kind of frameworks do we have? And how do they work? You have, it simplifies client and server development. Typically on a client, it provides marshalling, converting function parameters to application language to SOAP and XML types. And you have the SOAP protocol handling. For the server, it enables dispatching, selecting application language function implementing the called operation, so you can provide a WSDL file and you can have a server that parses this WSDL file and puts or exposes the API based on what the WSDL file says. It also provides unmarshalling, converting function parameters to SOAP XML types to application language. And of course, SOAP protocol handling. So your application code here, Java, PHP, C#, uses the WSDL lookup. It marshals or unmarshals, and it handles the SOAP protocol handling. Then you communicate upon HTTP with SOAP. And on the server side, you typically also have maybe a different language. It provides dispatching, unmarshalling of objects, and SOAP protocol handling. In this way, we can make remote procedure calls with SOAP and WSDL. And then you can have one service built on PHP, another service built on Java, built on .NET, built on Python or whatever, and you can have them communicate together with these specifications and standards. Any questions? No? Everything is clear about WSDL and web services?
You might have mentioned it somewhat, but what's the benefit of using something like SOAP over REST?
Oh, no benefits at all. You typically don't do it.
So we shouldn't
But
learn
it
this?
is possible to do it, but you don't. Because if you, yeah, oh, yeah. That's the answer.
Well, probably.
Yeah, but it's a valid question. It's a good question as well. So, but typically you don't use SOAP over HTTP with the REST applications. But we have to remember that REST, that's an architecture, and web services are actual specifications. REST, there are no specifications in REST. That's only a description of a way to do it. And typically a way to do it is upon HTTP and doing REST requests and responses there.
Yeah, here we have protocol.
Yeah,
It's
exactly.
fine. Yeah. And probably it's more flexible because I saw that in the header there can be extensions.
Yeah.
Yeah. So probably you can extend it with something.
Yeah, we'll come to some of the extensions that you can do to SOAP envelopes as, in a later lecture.
Is SOAP on the way out, or is it going steadily?
It's still used widely in enterprise systems, where you want to automate more than you want in systems that you develop directly. Typically WSDL, that's a great thing, actually, because it's typically when you don't generate these WSDL files yourself. You write an ordinary API in your programming language, and you let the library generate this WSDL file. What you can do then is that you can have an other client automatically detect changes in your WSDL file, detect changes in your interfaces, and actually set up the interface for you. So that's actually a great thing. With REST APIs, you typically use this. You do this manually. You implement everything more. You have no specifications to set up REST APIs. You have some general ideas of how it should be done. Like for Angular, you have the REST Angular idea. Are there any Angular developers here? No? Some of you. Have you heard about REST Angular? The way to do REST in Angular applications. And you have other type of REST ideas as well. But REST in itself, we'll come back to that. I will tell you more about that. But REST in itself is only an idea of how to do service orientation. We'll skip quite rapidly through UDDI because it is almost not used at all. But I'll tell you some things about it. Okay, service lookup, UDDI, Universal Description, Discovery and Integration. UDDI is only a specification of an API. So it's up to those implementing UDI servers to implement it based on how it's defined. More or less how DOM. Do you remember that I said to you that DOM is a higher level API, and implementers implement typical platform-specific versions of it, like in JavaScript or PHP or and so on and so on. More or less the same thing with UDI. It's just an interface of how a directory service for web services should be and what methods it should expose. So it's a directory for storing information about web services. So you can look at this as this list of web services that you have categorized in different ways, and you can ask for services in a specific domain or something like that. It's a directory of web service interfaces described by a WSDL. So a service can maybe register on a UDI server and provide a WSDL file that describes the interface that this web service is exposing. It communicates via SOAP. It's built into the Microsoft .NET platform. Typically, you have a conceptual model for UDI. You have information fields. In this directory, you need business name for the service, text description, contact information, business identifiers, and a taxonomy of business categories. So you can categorize these services based on what kind of business it belongs to. One API is the inquiry API. You can find web service and get details. One method that is specified is find business and get business detail, and there are others as well. Publishing API is for publishing a new service. Save service or delete business. And for security, you can use get auth token, discard auth token. It's quite a, yeah. So that was UDI. Don't have to think a lot about UDIs. They aren't widely used at all. But they are a part of this web service stack. You have VSDL for service description. You have SOAP for service communication, and you have UDI for service register. So these are the typical three components of web services. I suppose you have heard the term web service before this lecture today, but this is the actual web services specifications that are out there. And these are made by W3C. There are specifications under W3C. Yes. We'll have a workshop today as well. We got a little bit more time today than we did last time. How did you do with the last workshop? Did you get this Instagram application up and running?
Yes, but the link to this Instagram API, I mean the concrete link of searching some information, it's not working anymore, so we have to use another one.
But you found that in documentation, I suppose? Yeah.
And well, one problem that was there is that when you perform this request from client side, getting this information, we are facing with the problem of origin, access origin error. Yeah, and
But how?
How
It
to-
does a request. First, you are asked to authorize, I suppose,
yeah, well, authorized, and I mean,
and then you get some kind of access token, don't you?
yes,
Yeah, and you use that for your request, and the request also should have a callback, as far as I remember.
The problem is that we are performing requests from client side, and the request domain doesn't match, of course, the domain of the website.
Yeah, you're doing it in JavaScript,
Yes.
JavaScript on your client. Yeah,
Yeah.
I see. Yeah, then you'll have some origin problems. Yes.
Yes,
Yes.
and the fix for that was to use JSON-P request.
Yeah.
And then, Instagram knows that we are making requests from this application, so for this origin, it allows you to make requests because you have access token connected with this application and everything. But it should be not just get request, but JSON-P get requests.
Yeah, but you got the JSON-P, you get requests.
Yeah, and
working.
network. Yeah.
Yeah, that works. Okay. Yeah, I can see that. You can fake this also with extensions for Chrome that allows origin anyhow. so there are ways to pass through that. Okay. And if you want to look back to that actual workshop, you can also do this on server side if you want to do that. Do the call server to server. But then you won't have the allow access to origin top.
You can't access any public data on Instagram because you're in the sandbox
No,
mode.
you can't.
So,
Yeah.
And but on this template in this workshop, did we had access to server-side files, or we should make it just by ourselves?
You make that by yourself.
Yeah.
Either you use the HIG servers and the account that you got there, or you set up a localhost server.
No. I mean the server-side code. Did we have access to it on this template thing that you showed?
Oh no, you didn't. I don't
Yeah.
think so. That was on the client side code.
It was really frustrating for me to look through all the files and wait, is the server? Is the server?
Okay, yeah.
And then the limitation.
But remember that you don't have to do it the ways that I say that you, or the ways that I provide in the workshop. If you stumble onto too many problems doing it that way, you fall back to your favorite programming language and do it from there. And that goes for all the workshops. Remember that. But I forgot about my node examples just for the ease of it. Yeah. I also provide you with a generator in this exercise. Let's talk about this exercise. Exercise 4.1 and 4.2 on page 69 in the book Service-Oriented Computing. An alternative to installing the frameworks described in 4.1 is to set up services with Node.js and a YOML generator called Angular Full Stack. In the same way we did last time with YOML. You have to look or read up on how Node does stuff there. If you're using the Angular Full Stack generator, because that sets up a Node server with an Angular client. So you typically do your requests to the remote server through Node. And I think it asks you to either install MongoDB or don't install it. We don't need any databases for these examples. And it also asks you several different questions that I don't remember anymore. Okay, we'll take a 15-minute break. No, we don't. If you want to, you can take a break. But I will sit here and be available for you in the workshop. But I have to leave a little bit earlier today than I did last time. So I'll leave maybe 3:30 or something like that. Maybe a little bit later. Okay. But if you want to work with the workshop now with my assistance, you can do so.